Let us do some work on the compiler for the Elna programming language written in itself. Last time I started to modify the call instruction, procedure call instruction in the intermediate representation, because current call instruction depend on hardware registers, and the intermediate representation should not use the hardware registers directly. It should be hardware independent. So we have to find where we generate the calls. And it is actually here. So I need to do some work twice, or generate some instruction twice, probably, because I want that the call instructions continue to work with their old structure, but actually we just want to have an instruction call in there, and this instruction has two operands. The first operand is the symbol, so this is the name of the procedure, and the second operand is a list of arguments, and I set this list to the arguments operand variable, and this variable is an array with the arguments of the procedure. It will also make it possible to support more arguments, because the current procedure implementation supports only 7 arguments at most. I think actually that I probably already finished this part, so it would be interesting to see where we generate the RTL from this procs call instruction. Or let us split the screen and look where it is used. So here I just generate a jump instruction for the call, but otherwise it remains unchanged, and this is not actually correct. So do we have a procedure called Elna RTL call? We do not have one, so we are going to define it, because the handling of procedure calls will probably take some space, so we do not want to make this RTL instruction function even longer, because it is already long enough. So we just pass the instruction to this, or probably just the same arguments to this procedure, an instruction list pointer, begin and end, and we copy. So it just generates a jump and link instruction, copies the symbol name, the procedure name into the first operand, this is actually, this isn't wrong actually. So we need to copy the second operand, but not the first operand, but not the second one. So we define the result variable. And we return it. Now we can replace these two lines with Elna RTL call, and we pass the TSC instruction and next instruction to it. So yeah, let us get the argument count. The argument count will be basically the length of the second operand. So it is a TSC instruction. That means that the procedure is called Elna TSC instruction get length, and the first argument is TSC instruction. The second one is the operand number, and that's it, I think. Get operand length probably. Yeah. Get operand length. So it compiles now, and then we need the arguments itself. Let it be current argument, and the current argument will be the value. It is the pointer to the first argument. And then we can build a loop, I suppose. So we call it current argument. Then we define a label because we haven't implemented while statements yet. And we call it Elna RTL call loop, for example. And we check whether argument count is greater than 0, and then if this is the case, then argument count, then we decrement it, arguments count minus 1 and we jump to the loop label, RTL call loop. So we now have a list of arguments. So also we can each argument representation in the array is 12-bit long. So actually we also can increment this current argument by 12 to get to the next to the next array element. And then we can extract the elements of the structure that is saved in the array. So we save basically 3 things: argument type, argument value, and argument length. Argument type is the first field of the array element, so it can be accessed just as this. Then we add 4 bytes to go to the next element and to the next field of the element, and this is the argument value, and we can just add 4 once again, and this will be argument length. And we need to add 4 one last time to go to the next element of the array. After that, we need to copy the argument value into a register. So we would create an RTL instruction create, probably. It accepts the kind of the instruction, so RTL instruction create, and the kind would be ELNA RTL operator. I think it is called move. Let us define a variable argument move, and we assign this move instruction to this argument move variable. So, and then the first argument of the move instruction is the target, and the second argument is the source. So basically I want to set instruction set operand on the newly created instruction argument move, and we set first the second argument. We set it to the argument type, argument value, and argument length. That is done, and now we need to set the second argument. We want still support only 7 or 8 arguments, so the only arguments that can be passed in the registers. RISC-V has A0, A1, A2, and the last one is A7 registers for passing arguments to the function. And I actually have a list here. So this one is 0. I think A0 is the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th. Yeah, because enumeration is translated into a number beginning with 1. This is actually the 10th instruction, the 10th member of the enumeration. 11th, I say it. We cannot use argument count. We also need something like argument number to count the registers. Let us call it current register. We will set it to 0. I would say first. So current register is 0, and we will increment it on each loop iteration. So current register is then current register plus 1. And now we can set the second argument as well. So we set its type will be ELNA RTL operand register, and its value will be ELNA RTL register A0 plus current register. So that should do the trick, and the length is 0. Now we define a first instruction variable, and we initialize this first instruction to nil. And actually, if first instruction is nil, then we assign, we need first instruction because we need to return it from this procedure, so actually the result will be the first instruction. We assign this argument move to the first instruction, else. So on the first iteration, first instruction will be set. After the first iteration, we also need something like current instruction, so we keep track of the current instruction, and in this case current instruction would be the same instruction, so it would be just the argument move. On the second iteration, first instruction would be already nil, so but we know also that the current instruction is set, and the current instruction is the last instruction currently created. So actually we want a tail instruction concatenate, I think, and we want to append to the current instruction the newly created argument move instruction, and then we want to set the current instruction to the last instruction again. No instruction list. Instruction list. So we visit all arguments, and then we exit the loop. Now we need to create this jump and link instruction we created at the beginning, so we can move this creation at a later stage. I think result isn't used here anyway. for RTL we really do have only one argument, so it is the name of the procedure that we want to call, and all other arguments are basically registers that are set before the procedure is called. So we shouldn't copy any other arguments, but we should merge the lists with, so we have to append this jump and link instruction to the list of instructions that put arguments into the appropriate registers. And we can, if the procedure has no arguments, then first instruction will still be 0 or nil, and then if this is the case, then we can assign this result instruction to the first instruction. And if this is not the case, then the current instruction is set, so the first instruction remains as is, but we need to append these this result instruction to the current instruction, and current instruction is anyways this result. So we can assign the last instruction to this next instruction argument. Next instruction, I think that I did not set instruction here. Do I really need to do that? Well, we'll try it. So next instruction is then current instruction. No, result. So, and we need to return the first instruction and not the result. The result is appended to the first instruction now. Okay. We can reduce the number of used variables probably a bit, so I can just use argument move as a result, because it is used only for the arguments. Result can go then, or probably not. Okay. Let us look into the generated assembly. Instruction size has no arguments. Malloc has a single argument. Let us do the task a bit easier. So we just define a small or two small test procedures. The one of them will be called F, and we actually do not need to define any attributes since we do not check them anyway. And the one another one will be G. In G we'll call F with 5 as argument, and we compile it. And then we find them in assembly, so we are interested in G actually. So this is the call. This is an epilogue. We load 5 in x5. This is t0, I think. Then we move x5 into x29. When we store x29 on stack, and then we load it back from the stack. here we store the arguments on the stack, and here we load them back from the stack. And loading from the stack shouldn't be, and here I actually really do 11 plus argument count. Loading from the stack should not be needed. Since we do it later in this RTL pass. But I doubt that that it works. So it loads 5 in x5, then it moves x5 into x29, and then it writes x29 into the stack. But it doesn't load it back. That means that we do not append these instructions correctly here. Let us look for printf. So just for testing, I go to create name and name length variables, and I'm going to assign values to them. Actually, argument type is not assigned. Oh. Or is it done later? Argument type, argument value, and argument length. So let us get the procedure name, name and name length. This is the first operand, value and operand length. And let's print it as a comment into the assembly. Name length and name pointer. So I now get a list of procedures. And this is the procedures that we try to call. And we actually want to produce this debug output only in the case that the procedure that we are calling is this F procedure. So if string compare f1 of length 1 and name length, then do this. So let us print some information about it. For example, how many arguments does it have? We put an I in here, and we've already read the argument count, and we just put it as the next argument to printf. Probably the length is wrong by 1. Yeah. So we are going back. Here we generate the call and we calculate the arguments. If I just put +1 here, it won't probably help. So we can activate this basically again for now. We can try to remove it later. So I set the argument count to 0, and then I go through the expressions. If the first expression is nil, then I always reset the argument count to 0. That's of course not very smart. So we just want to move this instruction before we begin the loop, and when I can remove this argument count again. Okay, it compiles the list again. F has one argument. Let us look at the generated code. And here we have what we want. So I load a local variable into the register x10. I think it is A0, and I do it once again. So the one instruction is generated by the old code, and the new instruction is generated, or the second instruction is generated by the new code. Let us try to remove this thing once again. And that does the trick. So we can remove this one. I haven't looked what variables I used there. Probably I can remove some variables. So the instructions that we generate here are instructions to compile the arguments, because the call arguments can be expressions themselves, and I still need to check if the first instruction is nil and set it to call. It's basically pretty the same as we do later in the RTL, but in the RTL we do it for the argument array from the TIC code, and here we do a similar thing for lowering the abstract syntax tree into the 3 address code. So argument count is used, name length, name is probably used, parts expression is used, instruction is used, pretty sure. Instruction is used here, for example, and here we use all these operand things. Current instruction is used. Yes, current instruction is used. Arguments operand, I think so. Call instruction and name buffer is used for generating the names for the local variables. So this block name buffer as printf Okay, that looks fine now. I hope I haven't broken something. I think I haven't changed anything. So let us now go to the other procedure, this RTL call generator, and here we do not need this debug code anymore, so it can be removed. But the rest seems to be fine. So first instruction, current register, argument, current argument. Okay, that's fine, and then we can remove these test functions.